The problem we will be reviewing today is a quarry jumping problem. A young boy runs and jumps off the edge of a cliff and into a quarry. The boy's initial velocity is 10 meters per second. The height of the cliff is 13 meters. How far away from the cliff will the boy be when he lands in the water? If a second boy runs and jumps off the same cliff with an initial velocity of 8 meters per second, how far apart will the two boys be after landing in the water? The first thing we want to do is fill out what we know. For horizontal, we know that the initial velocity is 10 meters per second because that is given in the problem. This means that the final velocity is also 10 meters per second because it's horizontal and the velocity will remain the same. This also relates to the fact that the acceleration is 0 meters per second squared because it's horizontal. We don't know the displacement for horizontal or the time. Now for the vertical side of our chart, we know that the initial velocity is 0 meters per second, and the acceleration is negative 9.8 meters per second squared because it's vertical and it's going down because of gravity. The problem also tells us that the vertical displacement is 13 meters because that's the height of the cliff. We don't know the time. The first thing we want to do is find the time so that we can use that to figure out the rest of our problem. Now, to start finding the time, if you look to the right, we want to use the equation t equals the square root of 2 displacement over acceleration. Now that we have our equation, we want to plug in the numbers for time. This will give us the root of 2 times 13 meters divided by the acceleration, which is negative 9.8 meters per second squared. Make sure you use unit analysis to make sure your units come out right. Once we find this and simplify it, we want to find the square root. We find that our time is 1.63 seconds. So go back over to your chart and fill in the times on the chart. Now, the only thing left on our horizontal side of the chart is our displacement. We want to find displacement because this will answer the question, how far away from the cliff did the boy land in the water? Now to find the displacement, we want to use the equation initial velocity times time plus 1/2 at squared, which is 1/2 times acceleration times time squared. However, our acceleration is 0 meters per second squared, so we can cancel out this part of the equation. That gives us 10 meters per second, the initial velocity, times the time, 1.63 seconds. This will give us 16.3 meters, which we can then fill out on our chart and answer the first part of the question, which is that the boy lands in the water 16.3 meters from the cliff. Now we want to find out how far away from the cliff will the second boy land. Now, the things we need to change in our chart is the initial velocity for horizontal, which is now 8 meters per second instead of 10 meters per second. The final velocity is also 8 meters per second. Everything else in our chart that we started with in the what we know slide will remain the same. Now all we have to do to find out how far away from the cliff he will land is use the displacement equation. When filling out our displacement equation, we know that the second half of the equation will still come out to 0 because the acceleration has not changed from 0 meters per second squared. Therefore, we can get rid of the second part. Now, velocity initial times the time, so the new velocity, 8 meters per second, times the same time, 1.63 seconds. After doing the math, we determined that the displacement is 13.04 meters. So go ahead and put this into your chart. Looking at our diagram, we know that one boy will land in the water and one boy will land near him in the water. We know that they won't land at the same point because they have different initial velocities. For the first boy, with 10 meters per second as his initial velocity, we determined that he would land 16.3 meters from the cliff. For the second boy, with an initial velocity of 8 meters per second, we determined that he would land 13.04 meters from the cliff. Now, in order to find out how far apart they are, we want to subtract 16.3 meters minus 13.04 meters. This will come out to 3.26 meters, and this tells us how far apart they are in the water. Thank you for watching. I hope you successfully learned how to complete today's problem. We answered 2 parts to a question. Good job!